Welcome everyone. So this is the first session on Unity 3D. So today we'll be learning the basics about the interface of Unity 3D, what Unity 3D is, and the basic uh, terminology associated with Unity 3D. So first of all, what is Unity? Unity is a game engine. Game engine is a system designed to create video games. So basically it has a combination of many things which can be used in creating games, and it's also component based, meaning every game object, which we'll be seeing what are game objects. So game objects have smaller properties in them called components. So what can Unity do for us? It has a lot of stuff like animation, audio, physics, and controller input, and lots of things it combines in one software. So that's why it's a game engine. Even in the pro version we also have artificial intelligence, networking, and much stuff which we might need for making a very big video game. So also it is platform, it's cross platform, meaning you have a lot of platforms in which you can support your apps like PS3, iOS, Apple, Windows, Linux, and so on. And basically Unity scripting is done in three languages: JavaScript, C Sharp, and Do. So we'll be seeing the C Sharp scripting thing, because C Sharp is very similar to Java and C also. So we'll be doing that in C Sharp. So let me talk about the basic architecture of Unity first, before I show you the interface. So in a game we have assets and scenes. So assets are any files of the game which we might need. Like for the game you might need background music, you might need animation files, you might need lot of other external stuff which is not in the package. Like you might need your own custom images. So all these custom files are called assets. And scenes are basically one particular level of the game. So assets and scenes comprise the whole game. And the game has game objects, and game objects have components. So game objects are any object in the scene which have many properties, and you can play around with a lot of these to create lots of levels and lots of things in a game. So initially you will come up with this particular screen over here. So what you do is click on new, and let's say name your project, say test app, and choose the projects folder. The project usually takes a lot of space sometimes, so that's why I give a folder with much space. And let's say create. Okay, I already have this. Yeah, so create. So Unity is loading now, and yeah, so it's opening up now. And so this is how Unity looks like. So over here we have the hierarchy window, over here we have the inspector window, and down we have the console and the project window. So in the project window are basically all our files which we need for the project. So initially Unity has this folder called assets, and under that folder it has a folder called scenes, and in that it has a sample scene which is currently being shown over here. So the sample scene you can see in the hierarchy window. So the sample scene has a main camera and a directional light. So these are two default things given to us by Unity. So a main camera is basically used to show any to render any particular thing. So if you don't have this, you can't see anything. So, and directional light is for the lighting, so that's by default given to us by Unity's sample scene. So that is basically the hierarchy window, and in the middle you can see this particular thing is the scene window. So here is actually we add objects and play around, and the real time thing of Unity, we can see it over here. I can play around with objects over here in this scene view. And there's another thing called game view, so that will preview the app, so how the app will look from the camera's perspective when we run it. So that's basically it. And in the inspector window, this is a very important window. When we click on a particular object in the hierarchy, it shows us the properties of that particular object. So you can see directional light has transform and light properties, and main camera has transform, component, audio listener. So basically all these properties are nothing but components. These are called components, and the whole object itself is called as a game object. So there are a lot of game objects in Unity. So let me start off by creating one basic game object over here. So in the hierarchy window, I just say right click and 3D object and cube. So as you can see, the cube is being created over here in the scene view. So now let me show you these tools over here. There are 6 tools right over here. So let me tell you what are these 6 tools. So the first one is the hand tool. The hand tool is used to move around the scene view in Unity. So you just need to span around, or yeah, so you need to move around. You don't have to move the object actually, but you need to move your perspective around. So for that we use the hand tool. And if we right click the mouse, and then if we hover the mouse, you can see we have a free view. So we have a combination of free view and spanning the view. And also the scroll wheel is used to zoom in and zoom out. So with the combination of this, you can focus the camera over here. So let me focus it over here, and we can see the game view. So actually the camera is below the cube, so you can see the cube looks like this currently. So if I take the camera, and yeah, so that was the hand tool, right? Now let me show you the other tools. So transform. So this is the move tool. So this has many the 3 axes. So this is the y axis, this is the x axis, and this is the z axis. So you need to click on any one of these axes, and then you can just drag your mouse to move it up and down. And this is for left and right, and you can see the camera preview below, and this is for front and back. So let me focus on the cube. Yeah, so this is basically the move tool. And not only by fixing the axis, but you can also move by fixing a particular plane. So let's say I want to move in the YZ plane. So this is the y axis and this is the z axis. You can see in between both the axes there's a small square. You can see there are 3 squares over here. So each square represents the XY, YZ and ZX plane. So if I want to move in the YZ plane, so Y and Z, this is the square. So I hold that, I click on that and hold it, and then move the mouse. So I can freely move in the YZ plane. So the X will be fixed at that particular instant. So that's basically it. And alternative to the move tool, we have in the inspector window, we have the transform component, and the transform component has a position property. So when we change this position, it's the same as changing it via that. So you can see 1 1 1, so I can do that. So let me go back to the previous position where it's focused. So yeah, and you can also change the position by take your mouse near to the X, Y and Z letters over there, and you can actually click and move your mouse left and right to adjust X, Y and Z values. So that's the alternative to the move tool. And the next tool we have is the rotate tool. So rotate tool is the same thing as move tool, but it's used to rotate in all the three axes. So this is one axis, this is the other axis, and this is the other axis. This is the around the y axis. So you can see all the three axes you can move around this. And the alternative to that would be in the inspector window, transform and rotation. So let me set the rotation back to 0 0 0. So yeah, the next tool we have is the scale tool. So this is used to scale game objects. So let me do this on the cube, because on the camera it doesn't make sense to scale the camera. So this is along the y axis. So you can see I can scale the cube along the y axis and the z axis and the x axis. So let me make like a small plane over here, and what the camera can see. Yeah, so let me, so the camera can see this under. So let this be like a ground for now. Okay, I need to bring it. Mm, yeah, so let me just, yeah, so that's the ground we will be seeing. So okay, and the alternative to the scale tool is again the scale over here. So you can set the values over here. And the next tool we have is the rect tool. So the rect tool is usually used for 2D objects to scale the rectangular faces or anything. So over here you can see, to scale the rectangular face of this 3D object we can use the rect tool, but it's usually used for UI. It's not used over here. So UI also will be seen. And the final tool is the newly released tool. So it's a combination of all the tools. You can see there's the move tool, there's the scale tool, and this is the rotate tool. So it's a combination of all the tools. I would not recommend using this because uh, things might get pretty messy trying to get the cursor at the correct place. So using the separate tools one by one is a better choice. So yeah, so those are basically the top 6 tools. So these are very important tools whenever we have to place our game objects in the scene. So let me create another game object, let's say a sphere, and let me use the move tool to move the sphere on top. And let's see how the camera, so in the camera it's like this. Okay, let me bring it inside. Yeah, so you can see every game object has these components. So the first one we discussed was transform component. The next one is the mesh component. Mesh component is basically to make, while making a 3D model you have a network of points which determine the shape. So that particular network of points form a mesh. So that mesh is a cube mesh over here for the cube object, and it's a sphere mesh over here for the sphere object. So that's the mesh thing. And the mesh renderer takes the mesh which was on top, and it renders it in a particular fashion, what you can see over here. So over here we have a lot of properties in the mesh renderer again, just like in transform we had some particular properties. So in the mesh renderer we have properties like cache shadows, receive shadows. So if I say off cache shadows, so it will not cast its own shadow. And if I turn off the receive shadows, you can see the shadow just disappeared over there. So that's what it is. And this particular component, box collider, is very important. Box collider is basically used to determine collision, and to say that this is a wall, so nothing can pass through it. So I'll be showing you that properly. So let's see now what happens. So the sphere is right above the plane, so let me click on the play button. So you can see both are static, there's no movement. And this is because the laws of physics are not yet added to the particular game object. Both the cube and the sphere don't know. They are just mesh renderer. They have just mesh renderer and a collider object. So that doesn't make them follow the laws of physics or gravity or anything like that. So for that we need a new component. So I say add component, and in add component you can go to physics over here, and in physics you can see rigid body, or you can just search for rigid body over here by typing in like that. So when you click on rigid body, you can see the rigid body gives us the all the kinematic properties of a body. So this is the mass of the body, linear drag of the body, angular drag. So we can use this for more complicated purposes, and use gravity. So this determines if there is gravity or not. And is kinematic is basically used to tell a particular object that this object will be static, but it will follow the laws of gravity. That is, like, if anything falls on it, it will follow the laws of physics. So for that we use this kinematic. So let me make this add a rigid body component to this also, and make it kinematic. And this is not kinematic and it uses gravity. So both of them use gravity, but this is kinematic, so this will be static. So let's see what will happen now. So as you can see, this was static because it was kinematic, and the sphere just used this gravity and fell on the surface. So and also, if I don't have the box collider, what will happen? So I told you the collider is a very important thing. So if you don't have a collider, you can see it penetrates through the surface, so you won't actually know that this is a wall or this is a barrier at which the object has to stop. So that is determined by the box collider. So these tick marks, basically you can enable and disable components over here. See, if I disable the mesh renderer, there is no mesh, so it will be invisible. So like that. uh, so yeah, that's basically it. So now let me also show you UI. So in UI we have you right click and go to UI, and let's say I want to add a text. So as you can see, when I add a UI element, there's a canvas automatically added to it. So the canvas is basically a holder of all UI elements, and it acts as a screen. So if I double click on it, you can see over here, so it's a rectangle over here. So this represents our screen. So if you want to add anything to it, over here the text is over here, right? So let me move the text somewhere up. And while doing UI, I would recommend to click on this small 2D icon over here. So it will give you the 2D view, so you can see the UI clearly and the canvas clearly. So now you can see the canvas clearly, and this is our text thing which we just added. So let me move the text. We can even use the move tool over here. So move tool and the rotate tool, same tools as discussed. So let me also use the rect tool. Now here is where the rect tool comes in important. So I use the rect tool to scale it big. Now you can see the text has these particular properties or components. So in that, one particular component is the text script, and that has a particular text. So let me change the text to hello world, and you can see the text over there has changed to hello world, but it's very small. So let me increase the font size, or let me just say best fit. So it'll automatically increase the font size to fit the best. And you can also change the color to a different color. So there's a lot of things to play around with over here. And you can alternative to the move tool and the rotate tool and everything, you have the same things over here, rect transform. So if you change the position X to something else, you can see it's moving left and right, and position Y up and down, and Z is 0 because this is a 2D surface. So let me so this is a text UI element added. So let me play and show you what is happening. So you can see the things are the same, but this hello world was appears at the same place where it was placed in the canvas. So the canvas is acting like a screen. So wherever we place in a particular canvas, there from there, uh, that will be our screen basically. Uh, that is excluding the game objects, only the UI elements. So canvas is used only for the UI elements. So also let me add a button over here. So right click UI button, and the button has a text within it because it has a particular text written on it. As you can see, now the text is button. So let me change the text to click me, and over here again we have a lot of attributes in the text as discussed earlier, and in the button again we have a lot of attributes over here. So you can see this image is actually the background color of the button. So let me change it, and over here you can see on click, and it says list is empty. So this on click is where we'll be adding our written functions, what we write with C# scripting. We'll be calling those functions over here, and we'll be adding them via this. So presently it's empty, so let us see where it is in the canvas. So let me place it somewhere in the top right, and let's click play now. So now you can see as the on click list is empty, if I click, nothing is happening actually. So to make something happen, let's write a small script. So for writing a script, we but before writing a script for the button, I would like to write I would like to show you a simple script written on the sphere. So let me take out the click on the 2D again to switch to the 3D view. So over here let me say uh, let me disable gravity for now, and let me say add component, and over here you can say new script and name the script to be something. So let's say test, and language is C#, create and add, and you can see the script is being added to the game object. So to open the script, we double click over here, and the script should open up in Visual Studio or Mono Develop. Any editor should be fine. So it's loading. Yeah, so now you can see there are two methods over here. These two methods are the fundamental methods of uh, any script in Unity. So the first method is the start method. The start method is used for initializing our variables, and it's only called once when the game object is instantiated. Instantiated means it's spawned. So that means when I come to that particular scene and the game object has just appeared, has just rendered, so that time this start button, this start function will be called, and it will be called only once. So whatever you declare over here, you use this for initializing the variables. You declare the variables outside, any public variables outside. You initialize the variables inside the start method, and you can use those variables in the update method. So first let's see how to move this sphere. Okay, so for that we say there are two fundamental things over here. One is the small g game object and one is the capital G game object. So the small g game object represents the game object to which this script is attached. So this test.cs was attached to the sphere. So whenever I say small g game object, it'll refer to this sphere. Okay, and this capital G game object is a data type. It's basically from the you have over here, you can see there's a namespace using Unity engine. So in that Unity engine we have a lot of data types in the sense they are classes actually. So they're this game object is one of that class, and this game object is used to store the reference to other game objects we might need. So small g game object is used to store references to this particular game object, and capital G game object is a class whose object you will create to store the other game objects. So let me show you a bit more. So initially, suppose I want to get the position of the game object of this sphere. So I say game object dot transform dot position. So game object dot transform dot position. So this will give me a vector 3. A vector 3 means it has three attributes x, y and z. So you can dot, if you do, you can see x dot y and dot z. So these three are the attributes within position. And we also have the data type vector 2, vector 3. Vector 2 is used for 2D games and vector 3 is used for 3D games. So vector 3 is a data type, and let's say pause is equal to game object dot transform dot position. So the position gets stored into this particular vector 3, and as I said, this is used for initialization. Usually the declaration is done over here. So vector 3 pause, and pause is equal to this. So if I want to show the position of the sphere at every frame, this update function is the function where we'll be doing all our dynamic things like animations and lot of physics checking and lot of things. Like you need to check at every particular point whether your game object is performing some action or not. So that is done in the update function. So the update function is called once per frame, and based on your computer's performance, your computer might give you 40, 50 or 60 fps. So that depends on the computer. So over here, let's say this thing is used usually for debugging. So let's say debug.log, and let me say pause. So this will show me the position of the sphere every time, and let me save the script and click on the play button. So in the console you can see in every frame the count of showing the position is increasing, and the position is same because the sphere is static currently. So that's the thing. And let's say I use gravity, and then play. So you can see the position has changed and it's continuously logging the same position. So now let me show you a method which will be used to move the object. So for that we use gameobject dot transform dot translate, and in this translate we give a vector 3, and the vector 3 will be the velocity vector. So velocity vector, yeah, you can say it's a velocity vector. So new, it's like creating objects in Java. So new vector 3, and how many units? Say 1 unit in the x direction, 1 unit, 0 units in the y direction, and 0 units in the z direction. So let's say this was our velocity vector. So let's see what happens now. Okay, there seems to be transform or translate x. So okay, let's see what happens. Okay, there seems to be a problem. So game object to transform or translate new vector 3. Okay, oh, I've not saved it, I guess that's the problem. Yeah, so as you can see the game object just went away so fast. So why did this happen? Because update is called once every frame, and depending on your PC there might be 40 to 50 frames per second. So 1 unit in Unity means it's actually this much. 1 unit is this much, so 50 units per second. So you can imagine how fast the speed is. So that's why it was moving really fast, and to reduce this speed we use a constant called time dot delta time. So time dot delta time is a fixed constant, and it is 1 divided by frames per second, and that frames per second varies from PC to PC, but Unity will take care of that and give you the value in time dot delta time. So time dot delta time stores 1 by fps. So 1 by fps times this, if you do, it will give you a smooth motion. So let me show you what. So you can see it's moving 1 unit in 1 second. So that's basically it. So time dot delta time is the fixed constant which is used for smooth movement, because you don't want to move the game object very fast. This would move the object 50 units per second. So to reduce that we use time dot delta time. It's used in many places. So transform dot translate is the method. So now since you know this, uh, let's move on to another basic script. So let me disable the test script from the sphere, and let's, okay, let the gravity be off. And usually the button needs a method, right? So that method, I'll be creating an empty game object and rename that game object as something like UI manager. So this UI manager will manage all the UI elements, let's say, and say UI, and create a script, open the script. it has the same thing, start and update. So this is an empty game object, so I don't want to update it, or I don't want to initialize any things over here. So let me take out this and let me create my own method. Say button click. So in this button click, what will the button do when I click it? So let's say what I've done currently is the sphere doesn't have gravity, right? So let's say I want to enable the gravity when I click the button, enable or disable. I want to toggle the gravity of the sphere. So how will I do this? I'll get a reference to the sphere in this script. How will I get that? Because this is another class, right? So I'll have to use a capital G game object, and let's say sphere. So this is my reference to the sphere. I have not yet initialized it, but you will see why. And also I'll make it public because it's coming from another place. It's not local to this particular class, so I have to make it public game object sphere. And I have to make this method also public because this method will be used by the button, and the button is not a part of this class. You cannot add scripts to the button directly. You have to create an empty game object, or just create one empty game object and add many scripts to that, and then for each script add things to the button. Or you can even create one script with all the methods and then use that script for all the buttons. So that's a more recommended thing. So what you do is create one script, and for many button click 1, button click 2, button click 3, and so on, you can create a lot of methods, and you can use the same game object to manage multiple buttons. So that's the thing. So on the click of a button, what do I want to do? I want to do sphere dot get component is used to get the components of the sphere. So as I told you, the sphere has a lot of components, right? Transform, and you saw it has sphere collider, and you can see sphere has transform, mesh renderer, sphere collider, rigid body we just added. So I want to get which component, so that I write within these angular brackets. So I want to get the rigid body component, and dot gravity. So when I just type gr, it should be use gravity. So that's the variable. So use gravity is equal to true. So true will make it every time I click the button, will just make it true. So if I want to toggle it, uh, I say not of this whole thing. So but without that, let me just store this component. So again, as I said, Unity has many of these easy data types which you can use. So rigid body is another data type. So rigid body RB is equal to sphere dot get component rigid body. So this is my particular component from the sphere, and I say RB dot use gravity is equal to not of RB dot use gravity. So every time I click this button, it should toggle the gravity of the sphere. So now remember to make these two public, and you will see why. If you don't make it public, it won't work also. So only when I make it public, you can see I've added the script to UI manager. So let's go to UI manager, and 1 minute. So the UI manager has this UI script, and you can see since I made the sphere game object public, you have a slot over here called sphere, and it says none game object. So it's waiting for the reference of the sphere to be given. I have not initialized it in the script, right? So I need to give a reference to that. So how do I do that? I take the sphere from the hierarchy window and drag and drop it over there. So this is the benefit over here. Unity doesn't require a lot of scripting to get the references from lot of various classes. You can just drag and drop and it's done. So it's as simple as that. So the sphere variable got initialized to this sphere, and now it should work basically. So let's see. So initially there's no gravity. When I click the button, oh, nothing happened. This is because I've not added anything to the on click. So I told you there's an on click, right? So over here, as you can see, on click is empty. So I say add to list, and it's waiting for an object over here. So I drag the UI manager object over here, and it's waiting for a function. Which function do I call when the button is clicked? So I go over here, and these are the scripts basically. So UI is the script what I have written. So under UI I have button click as my, yeah, so button click. So this will not appear over here if you don't declare the method public. So it's very important to declare the method public, otherwise it won't appear over here. So when you click on button click, so yeah, so this method will be called whenever I click the button. So now if I click play, you can see the uh, when I click the button, then only the sphere started using gravity, and it just stopped over there when I click the button again. So this button is toggling the gravity of the sphere. So like this only we can get a lot of other components using the get component syntax right over here. And yeah, so this is a sample thing over here. And let's say you want to keep track of how many times you click the button or anything. So let's say this text which I had added, so let me enable 2D view again. So let's say this text I had added gives me a score of how many times I've clicked the button. So initially it's 0. So initially I've clicked the button 0 times, and as I click, this number should keep on increasing. So let's say I want to make this basic app. So for that, again in the UI manager, in the button click method over here, what I do is let's say I even do this, and also I change the text of the text box. So for using text in your Unity scripting, you say using Unity engine dot UI. So the text data type is defined in this namespace, so you have to use Unity engine.ui. So once you use Unity engine.ui, you easily have again I need to make a public, because it's from outside and I'll get a slot and I have to drag and drop over there. So public text, and this is my text box. So what I do is over here I say text box dot text. So text has directly dot text, so you can directly change the text over here. And for this we'll also need a variable to keep track of how many it got, or yeah, let's keep a variable, that would be easy. Public static int clicked 0 initially, dot text is equal to click clicked, and I need to convert this to string, so dot to string. So initially it will be 0, and let's say every time I click the button, okay, so first I increment clicked, so clicked plus is equal to 1. So every time I click the button, clicked will get incremented by 1, and the text box text will be changed to clicked. So let's see if this works. Alright, play. Oh, I need to drag and drop the reference, otherwise it's of no use. So I drag the text reference over here onto this. So now you can see as I click the button, the count is increasing. Yep. So this is another basic way of scripting. And what else do we have? And you can see over here your scripts what you have again appear in these project files, because the project window shows us all the files we need for a particular project. So that's included over here. And let me also show you how to change the material. Take out 2D, and the materials in Unity are used to tell the opaqueness and uh, roughness and lot of other things of the body, color of the body, metallic, how metallic it is, how elastic it is, and lots of other things. So for that, for creating a material, what we do, create right click, and over here in the project window, because in the hierarchy we can't create a material, because material is not a game object. So the material is actually a file which will store information about the game object. So we right click over here on the project and create, and we have a lot of things to create over here, but for now we'll be creating a material, a normal material. So let's name this mat. So yeah, and you can see rendering mode, opaque, transparent, a lot of options are there over here. So in this only we can change the color of the material, and a lot of other things like smoothness, metallic, and height map. We don't need all this actually. So yeah, so take the sphere, and if you want to add this material to the sphere, we just drag this material onto the sphere and it will get applied to it. So it's as simple as that. So we can create new materials for many game objects, and then apply them to various game objects. So that should be most of it. Yeah, so I've covered most of it. And you can see you can also create objects from here also, rigid body and a lot of other things. You can play around with the components from here also. And if you are not able to view Unity in this configuration what I have, like inspector, lighting, and a lot of other windows, if you're not able to see them, you just go to window over here, and just click on all of these windows, and then you can just drag and drop these windows to arrange them in this hierarchy. So I prefer this way of seeing the window. Yeah, so land, yeah. So that should be it, guys, I think. So, and sorry for the inconvenience during the stream. We had a lot of connection problems. We'll come up with an alternative. And thanks for seeing the video.